Hello, we are going to now see in-order traversal of trees. So this is in-order traversal of binary trees. Okay, so in-order is going to be defined only for binary trees. So I'll write the function, basically the algorithm, and then we will go through this example tree, right? How this traversal is going to happen, and it's going to look similar, very similar to the pre-order and post-order traversal. You will soon notice the difference. Right. This is in-order traversal. As you could see, where is the visit happening? So the visit is happening between the two recursive calls. So this is our visit. As you could see, in an in-order traversal, before you visit the node, you traverse the left subtree. You traverse the left subtree, then you visit that particular node, and then you go to the right subtree. This is in-order traversal. Let's recollect what is pre-order traversal. In pre-order traversal, the visit happened at first, and then the left and right subtree were traversed. In post-order traversal, you traverse both the left subtree and right subtree, followed by visiting the node. Right? And finally, we have in-order traversal, where you visit the left subtree and then yourself, then followed by the right subtree. Good. This is in-order traversal, and let's look at an example. Here is our tree, and so this tree, this is the tree which we drew, and it has been numbered based on pre-order traversal. Okay. Now, if you do a pre-order traversal of this tree, you get the numbers in sequence from 1 to 3 up to 15, in an ascending order of the numbers. Now you have this tree, and you are interested in in-order traversal of this tree. Let's see what happens. I first start off with the root subtree, right? So I'm here. I'm in the root node, and I have to first do an in-order traversal of the left tree. So I have to come here, right? I come here, come to this direction. So let me mark it. So I come here, the subtree, and I am at 2, and then I have to go take a left again, right? I go left. 3, I go left again. I finally reach the last vertex. Next thing, what will I do? Okay, so I'm going to print that node 5 because it does not have a left turn. There's nothing on the left, that is a null, and so nothing happens. And you print this value 5, right? So 5 is printed first. After that, it goes to the right of the node 5, and there's nothing, so it's done. And it comes up to 4, and so now you have finished this is the node, the node number 4, and you've finished this step. You've finished this step, and now you go and come and print here. Its value is 4, so you're going to print 4, followed by you traverse right, and you traverse right, and you get 6. And now, since you have finished traversing the entire left subtree, you go up. Okay. You go up and you print the value there, 3, followed by its right subtree, which is not there. Then you go up, you print 2, followed by its right subtree. So you come to 7, you go left. You come to 8, you go left, but there's nothing in the left, it's null. So you come back and you print, before you turn right, you print 8. Okay, then you turn right and print 9. You finished the entire left subtree of 7, so you print 7. You turn right of 7, there's nothing there. You go up, you have finished this entire left subtree up to 2. Right? So you have finished the entire left subtree of 1, and so you go to the, before you have to go right subtree of 1, but you have to print 1 before that. So you first print 1, then you go to the right subtree. You come to 10, you turn left, you go to 11, you turn left, you reach 12. There's nothing more to do, so you print 12. Once you have printed 12, you go up, you go to 11, you print 11. You turn right, it's null, so it's fine. You go done with all the left thing, you go and print 10. You turn right, 13, you turn left, 14. This is done. You go back 13, you come right, 15. Okay, this is the Inorder traversal. So let me just see whether this is correct. Okay, so let's just go through it in quickly, so that let's just see whether what I've done is correct. So I'm starting from the first. I go full left, I reach 5, I print 5, then I go back up 4, come down here 6, done, go back here 3, nothing there, go back here 2, come right 7, you don't print 7 right now, you go left, you print 8, after 2 you print 8, then you print 9, go up, print 7, this is done, you go up, print 1, turn left, turn right, turn left, 12, go up 11, go up 10, right 13, you don't print 13, but you have to go left 14, go back 13, come down 15. So this is the in-order traversal of this tree. Is it clear? Okay, good. Now, few things to see. Where is the leftmost corner of this tree? Sorry, where is the leftmost node? Which is the leftmost node? 5. Where is it in this list? It's on the right. Okay, so the leftmost node is going to be on the left. So it's a little tricky. What do I mean by leftmost node? Okay, because this is, let me just note down. So we have come here, and this is the leftmost node, but it has a right node. So let me say this is 5 and this is 9. In an in-order traversal, what will be the so what will be printed first? 5 or 9? 5 will be printed, right? Okay, so in-order traversal, this will be printed first, and this will be the leftmost node in in-order traversal. On the other hand, if it was a post-order traversal, which will be printed first, 5 or 9? So 9 will be printed. Okay, because only after it finishes both the left and right cell, only then it's going to come printed. So yeah, so in an in-order traversal, you go fully left, you go on, keep on taking left, and when there is no left turn to be taken, chosen, you stop and you print that. That's going to be the first node in an in-order traversal. That's not exactly what gets printed. That's not what gets printed in a post order traversal. So post order traversal, the first number which is printed is you come to the leftmost thing, and if there's nothing to the left of it but there is something to the right, you go right. Okay, once you take one right turn, then you keep on going left again until you hit again a node which does not have a left. Then you go right, one right, and then you go left again until you can't do this thing, and that's the node which is going to come first. And what about 15? Where does 15 comes? And as you can see, 15 is going to come on here. Okay, so this is what I'm saying is that the rightmost node. So you go, you take right, and there is nothing more right to be taken. Then that is the one which is going to come last. That's a number which is going to come last in a in-order traversal. Where is the root here? The root is somewhere here in the middle, right? Okay, it's in the middle because everything to its left had to be printed. So all these number which comes before 1 are to the left of the root. Now all the numbers which come right of 1 are to the right of this one. Okay, so this is a very important property of in-order traversal. Let's take a look at it again. So 1 is here. Look at all the numbers of 1 to the left of 1. Okay, it's going to come in this sequence. It's going to come before 1. Look at all the numbers which comes after 1. It's going to come on the rightmost, on the right side of 1. It's going to come after 1. This is a very important property, and this is recursively this is being implemented. You take 3, you take 4. The numbers to the left of 4 comes before 4, and the numbers to the right of 4 comes after 4. Okay, or 10. Let's take 10 here. The numbers to the left of 10 comes before 10, 12 and 11. The numbers to the right of 10 comes after 10, 14, 13, 15. This is a very important property of in-order traversal. Okay. Can the root node be the last element in an in-order traversal? Is there some situation that can happen? Yes, I claim it can. Consider this tree. What will be the in-order traversal of this tree? Right, I come to 1, I go left, I print 3, I come back, print 2, I go down, print 4, then I go up and print 1. Right, this is the in-order traversal. So in this case, 1 has come up. So again, when can the root becomes the rightmost element? When the root is also the rightmost element, right? Yeah. Okay. So so you can I can ask questions like this. Okay, can the root node be the first element? Just think about it. When can the root node be the first element in an in-order traversal? Right. So these kind of questions I can ask. Now I come to a very interesting thing, and what I'm going to do is the following. Okay. So this is the in-order traversal. And what is the pre-order traversal? The pre-order traversal is basically this number. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, this is our pre-order traversal. Now I claim the following. If you are given the pre-order traversal and in-order traversal of the tree, then you can construct the tree. Very interesting property. Given both the pre-order traversal and the in-order traversal of a tree, we can construct the tree. Let's do that. So I'm going to rub this tree off and see whether we can construct this tree back. Okay. Okay. So we are given the in-order traversal and pre-order traversal, and we are interested in constructing the tree back. Right. In a pre-order traversal, where is the root node? we discussed and we said the root node is going to be the first, right? So what is it I can do? I can first write the root node. Very easy. Look at the pre-order traversal and I get the root node. It's going to be the first number which is going to be printed. So the root number, once I know the root, I'm going to build the root. Now I can look at the Inorder traversal. Find where is the root. So okay, root is there. And then I use this property, which is the interesting property I had. What is the interesting property? Everything to the left of that root node, everything to the left of 1 is going to be in the left of 1. So all these numbers have to be on the left side of 1. Okay, and all the other numbers should be on the right side of 1. Right? Okay. So I am here. So let's try to construct the tree there. Okay, so this has to be from a tree where all these numbers are on the left of 1. Okay. Now, is there somehow I can write the left child? Okay. Yeah. So I look at in a pre-order traversal, I know. So it's pre-order, right? So if 2 is the next thing, what does it mean? This number has to be 2. Right. So I know I'm here 2. And I know the following thing. All these numbers should appear on the left of 2 and all these numbers should appear on the left of right of 2. So I know that there is something on the left. Right? So if there is something on the left, it should be printed after 2. So it has to be 3 here. So I am here 3. Okay. Now I know all these numbers on the left of 3, right, has to be on the left. So there has to be something on the left. On the other hand, there is nothing between 3 and 2. Right? So there's nothing on this side. Clear? So all these numbers on the left has to be here. So after 3, it is printed 4. So 4 has to be here. Now 4 is here. Okay. And after 4, 5 is printed. So 5. So since 4 is here, I know there's something on the left and 5 was there. So 5 is printed. And there's something on the right. So 6 is printed here. This is good. So I'm finished till here. Now I come to 7. Okay. So I finished everything till here. Right? So now there's only something on the right of 2. So I'm coming to the right of 2. Okay. So there's something on the right of 2. And so once I turn right, what is the first thing to be printed? That's the next one. So it's 7 here. So I'm here. Now there's nothing on the right of 7. But there are 2 numbers, 8 and 9 on the left of 7. So I see what is printed after 7, 8. It has to come here. 8 comes here. Is there anything to the left of 8? No, there's nothing to the left of 8 because there's nothing between 2 and 8. So this is. On the other hand, there is something to the right of 8, which is 9. I'm writing 9 because that's the only number there. Okay. So we have finished till 7, 8, 9. Now we are going to go to look at 10. So I mean, I have so see, we have done everything till here, right? So everything to the left of everything to the left subtree of 1 we have covered. Of this tree we have covered. So the root node 1 has some elements in the left subtree and we have covered the entire thing on the left subtree. Now we need to go to the right subtree. And I know there are some elements in the right subtree. And I turn right, and what should be the first element? It's going to be the one which has been printed after this entire left subtree has been printed, and that is number 10. It should come here. Okay, and I mark 10 here, and I notice it should have some left elements on the left of it and elements on the right of it. So there has to be something here, and I look at it and it has to be 11, right? I mark here and it has something on the left of it, so it has to be 12. So this is also done. Now there's nothing between 11 and 10, so there's nothing on the right of 11. Okay, so I have reached till 12. Now next thing I print is going to be on the right of this, which is 13. Okay, so I mark 13 here and it has one element on the left and one element on the right. So it has to be 14 here. It has to be 15 there. So what we have just now constructed is, from an in-order traversal and a pre-order traversal, we have constructed the tree back. So here is a claim. If you give me an in-order traversal and a pre-order traversal, I can build a tree, and it's a unique tree, exactly one tree I can build given an in-order traversal and a pre-order traversal. The two traversal fix the tree exactly how it should be. What about in-order traversal and post-order traversal? It's going to be symmetric, right? So pre-order is going to be is symmetric to post-order. So the same thing happens with an in-order and post-order also. Okay. And in-order traversal and post-order traversal also gives me a unique tree. This is an exercise for you. You can try this out. You can try to give an algorithm on how to build a tree from an in-order and a post-order traversal. Right? That's an algorithm which you should try doing. Got it? But what about the another question? If I give you a pre-order and a post-order traversal, can you build the tree? Listen carefully. I'm giving you a pre-order traversal and a post-order traversal. Can you build the tree back? And the answer is no. Why? Because there is no unique tree. That's the main claim. So you can't construct a unique tree from a pre-order and a post-order traversal simply because there is no unique tree. There can be multiple trees with the same in-order, same pre-order and a post-order traversal. Let's see whether we can try to build an example. So the pre-order traversal of this tree will be 2, 1. Post will be 1, 2. Yeah, so this is one tree. And what about this tree? So the pre-order traversal of this tree was 2 was printed first and then 1 was printed, right? And the post-order traversal of this tree printed 1 and then printed 2. Sorry, it's the other way. Sorry, the pre-order traversal printed 1 and then printed 2, and the post-order travel printed 2 and then 1. Sorry for the confusion. Now, what about this tree? What is the pre-order traversal? Pre-order traversal is going to print 1 and then it's going to print 2. And what about this? You get the picture. So there are these two. So if you are given 1, 2 and 2, 1 as pre and post order traversal, you don't know what is going to be the tree. The tree can be this or tree can be this, right? So this is a This is an example for the claim of this, right? So I'm constructing a tree. I'm constructing two sequences, a pre-order and a post-order sequence, and I'm saying there's no unique tree for these two sequences. There are, I mean, I'm giving two trees which are going to have the same two pre-order and post-order sequences. Thank you.